Yesterday we started the new topic, which is rate or the speed of the reaction. So factors affecting the rate or the speed of the reaction. Concentration or amount of reactant. Temperature. Surface area. Pressure. It's only valid for gases. Like pressure does not affect the rate or the speed for a solid reactants. It's only affect the gaseous reactant, solid and liquid reactants. The rate is not affected by the change in pressure. And catalyst, and external factors such as light. But this is only for specific kind of reaction, which is also called photochemical. Not all of the reactions are affected by light. So yesterday we discussed how the concentration or amount of the reactant affects the speed or the rate of the reaction. The second factor is the temperature. So what will be the effect on speed or the rate of the reaction if we increase the temperature? So basically, when we increase the temperature, it means we increase the kinetic energy of the particle. And when the kinetic energy increases, so if kinetic energy increase, it means speed of the particles increases. And when the speed of the particle increases, it means the particles will collide more often, which result in increase of rate. So basically, what happened, like example, you have say reactant particles. These are the reactant particles, say 5 reactant particles, but it is at 5 degrees centigrade. So what happened, these reactant particles, they are colliding with each other, but at 5 degrees centigrade, they are moving slow. So less collision means less likely they will form the product. But if we increase the temperature, same reaction we carry out at high temperature, example 50 degrees centigrade. So same number of the particles, but colliding at a higher temperature. So if they collide at a higher temperature, this results in more collision. As the number of the collision increase, speed of the particle increase, so they will collide often, and as the number of the collision increase, the reaction will be faster. but amount of the product will not change. Why amount of product will not change? Because you have 5 particles of reactant in experiment 1 or experiment A, and you have 5 particles in experiment B. So both experiments, you have the same number of particles. That's why the amount of the product, the final product, will be same. So if I want to sketch a graph to show amount of product or volume of a product with time at 5 degree centigrade, reaction at 5 degree, and reaction at 50. So on y-axis we have volume of product, and x-axis we have time. So at 5 degree, the reactant molecule, the particle collide or less collision, as they have or few collisions, the product will form, but slowly the product will form, and then the reaction will stop after some time. But it will take more time to complete the reaction. When the line is horizontal, it means the reaction completed. So this is the first graph is for experiment A at 5 degree. If I carry out the same experiment at higher temperature, example 50 degrees, so particles will have often they collide, and this will result in a faster rate. So the same reaction will end or finish in a short time. So this was experiment B, and this one is experiment A. And you can see experiment B is faster as compared to experiment A, and it completed in a short time. Amount of product is not changing. Why the amount of product is not changing? Because you have the same amount of reactant in both experiments. Amount of product depending on the amount of reactant used, but the speed of the reaction is affected by temperature as well. Is it clear, this concept of how temperature affects the speed or the rate of the chemical reaction? Any doubt in this? Same way, if we sketch for change in mass of a reactant or amount of reactant with respect to time, in the beginning, it will start with a maximum value of the reactant, and then it's slow down, and eventually it will stop. But if I say this was done at 5 degrees, now you want to sketch a graph at 50 degrees. So at 50, the reaction will be much faster. So steeper slope, in a short time, you will obtain a greater change in mass of the reactant, and then it will be constant. So when it start to be horizontal, it means the reaction end or finish. Both lines, these two lines should meet. Why? Because we did not change the amount of reactant. The thing which we change only is the temperature. So first reaction at 5 degree and the second reaction at 50 degree. So increasing a temperature will also increase the speed or rate of the chemical reaction. Is it clear? The two graphs. Any doubt? Take the screenshot of this. Then a factor which affects the rate or speed, that's the surface area. Surface area How a surface area affects the rate or the speed of a reaction? Mainly it affects, like, if there is one reactant is in a solid state, another one is aqueous or liquid. Aqueous means dissolve in water, or gas. So one of the reactants should be solid, other is in a liquid state, aqueous state, or a gaseous state. That time more likely a surface area will affect. So you can have large particle size, such as lumps, and you may have small particle size, example like powder or granules. So what happened, example, if there was a reaction between acid and metal, metal is reacting with acid. Acid is aqueous. All the acids are aqueous. They are all in water. They are present, and metal is there in a solid state. If we have a lump, so example, we have 2 grams of metal. So we have 2 grams of metal, and acid is there in excess. Means more than enough for a reaction. Here also we have 2 grams of metal, and acid is there in excess. Means more than enough for a complete reaction. But the first one, we have a large particle size. Example, we have a lump of the metal. So this is a lump of the metal. And the particles which are only at the surface can react. So it's 1, 2, particles which are exposed to the surface can only react. First. So how many particles can react here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. When we add an acid, because these are the particles which are exposed to the surface, so they can only react. The particles which are inside, initially they cannot react because they don't have any contact with the acid. But if I crush this into smaller pieces, so when I crush this or break this into smaller pieces, the same 2 grams but smaller particles, like in a powder form. So when I draw the structure for this, shows the particles at the surface. Same thing happened, the particles which are at the surface are exposed to the surrounding. So 1, 2, the particle size should be same. Maybe my particle size will not appear to be same, but it should be same because we have the same substance. The size of the atom, basically. The particle size is different, but size of the atom, which is present in a lump, it should be same as size of atom which is present in a powder. because it's the same substance, same magnesium is there. So when you crush this into smaller pieces, now what happened? How many particles are exposed here? So 1, 2, 3, 4. So each say particles means small particle size, 4 particles are exposed. The total almost 24 particles are exposed to the acid, because it can, any of them can react with acid. So which one will have a faster rate or speed of the reaction? Lumps or powder or granules? Which one will react faster with acid? Which of them will react faster with acid? The powder or the granule will react faster because there are more effective collagen. Look, for a lump, how many particles can react? Only 12. But as I divide this into smaller particles, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of these particles are exposed to the acid. So if all of these particles are exposed to the acid, means this will have more collagen. That's why it will have a faster rate. So which of them is having a large surface area? Lumps or powder or granules? Large surface area. So this will have, so whenever a particle size is smaller, a smaller particle size means it will have a large surface area. And large particle size means it will have a small surface area. Surface area, the area which is exposed to the surrounding, that's a surface area. So you can see when I measure this total surface area exposed, compared to, because for this one only the particle at the surface can react. But when I crush into smaller parts, I break this into smaller parts, so more particles are exposed to the surrounding. That's why this will have a faster rate or speed of the reaction. And you can understand this with a simple example. If you have sugar crystals, large sugar crystals or lumps, and you have a powder sugar, and you add to tea, which one will dissolve faster? Lump of sugar or powder or fine sugar? Which will dissolve faster? So the fine or the powder sugar will dissolve faster because more particles are exposed to the surrounding. Is it clear? This idea of the surface area on the speed or the rate of the reaction. So this is a solid which is having the particles, but the particles which are exposed to the surrounding will only react first. So few particles are exposed in the, when you're using a lump, and more particles are exposed when you're using a powder or granules. So if we sketch a speed or the rate of a reaction graph, so powder is reacting much faster as compared to lumps. Take the screenshot, then I will sketch the graph. So if we have the volume of product versus the time, in the first experiment we are using lumps. In the second experiment we crush and use a powder form. Which apparatus can be used to crush the solid? In lab, in chemistry lab, which apparatus we can use to crush this solid? The mortar and pestle. So mortar and pestle can be used to crush. So mortar and pestle, we put a solid here like the lumps, and then we'll apply the force using this. We can crush this solid. So if we use lumps, reaction in the beginning will be slower, means the rate will be slower. Eventually it will stop after some time. This is when you are using a lumps. If I use a powder form, because more particles exposed to the surrounding, so they will react faster, but the final product will be same. Because this is 2 grams of lumps and 2 grams of powder reacted. So both experiment we use the same amount. That's why the final product is same. But why steeper slope for powder form? Because more particles or particle have greater number of effective collision. That is why the speed is faster. And if there's another graph for mass of the amount of reactant, and time. So in the beginning, you will have greater amount of reactant, but with the passage of the time, amount of reactant decrease. And eventually it will be constant. When it is constant, it shows that the reaction stops. This is for the lumps. If you sketch the graph, change in amount of reactant for a powder. So in the beginning, much steeper slope, faster rate, and it will end in a short time. So that is for the powder. Powder form will have a large surface area and it is having small particle size. Size of the particle is small, but the surface area which is exposed is large. Lumps is having a small surface area. In short, I'm writing SSA, small surface area, but the particle size is large. Is it clear? How the speed of the reaction is affected by size of the particles. Any doubt in this? Take the screenshot. Then another factor which affects the rate, that's called pressure. It's only if reactant is a gas, or if any gas is there in a reactant, even one of the reactant is a gas or both reactant or three reactants are in a gaseous state, it will affect. So example, you have gas A reacting with gas B, and this result in a formation of gas C. So A and B, two gases are reacting, and this result in a formation of any other substance, example gas C. How the pressure affects, because for a gases, you have to, for a reaction of a gas, it should be inside a container. So example, you have two containers which are filled with same amount of two gases at same temperature. So this black shade is representing A and the red shade is representing B. So A and B will collide with each other. Gases, the particles are moving randomly and they collide with each other. Now, a same amount of gas, A and B, but in a small container. Or we reduce the volume or we increase the pressure. How we can reduce the volume or increase the pressure? It's by compressing it. So what we did, if the container is same, but we compress the gases are compressible. This is a piston. Piston is a movable lid, a lid which can be moved or position can be changed. That's called a piston. So a piston is, we push the piston so that the particle will occupy less space or less volume, but the same number of particles of A and B. So here we have large volume. Large volume means they have a small pressure, because the pressure of a gas or pressure on the gas refers to space occupied by the gas molecule. Here they are occupying larger volume, so they will collide less often with the wall or less often or less collision with each other. But when we increase the pressure, so as we increase the pressure, how we increase the pressure? By pushing this piston, a movable lid. So these gas particles occupy a smaller space. Which container means which case container is the same, which case they will collide or have more collision, first or the second. In which one they will have greater number of the collision in a unit time, first or the second example. So in the second container, because small space is there, so continuously, because the particle in a gas are moving randomly, so continuously they're moving and they hit each other. So as they hit each other, and more likely they will collide, and as they collide, this will result formation of a product in a short time. In container A, also in container, they will also collide, but the number of the collisions are relatively less. So if we have larger volume or small pressure, the less collision between the molecules. And here we have a small volume or high pressure, so they have more collision between the molecules of gas. So which one will react faster in reaction in container A or container 2? Sorry, container 1 or container 2? Which container they will have faster rate? So container 2, because more collisions are there, but the number of the gas molecules are same in both containers. So the amount of product will not change. The amount of product will be same. So this is at high pressure and the other one is at low pressure. Is it clear? The concept of factors which affects the speed or the rate of the chemical reaction. This is the third factor. First one was concentration, second is temperature, and the third one was pressure. Keep in sorry, this is the fourth one, because surface area also I discussed with you. So pressure is the fourth factor which affects the speed or the rate of a chemical reaction. Now some questions related to topic. The topic is not completed, but some questions related to a topic for understanding. A liquid X react with solid Y to form a gas. So a gas is given off or gas is a product. Which two diagrams shows a suitable method to investigate the rate or the speed of a reaction? How we can measure rate or speed of reaction? Either we can measure the volume of product or volume of a gas, or we can measure the change in the mass of the flask. Which method will work? So options are 1, 3, 1, 4, 2, 3 or 2, 4. Method 1 will not work. Why method 1 will not work? Because there's a cotton wool, so it is giving off gas. So gas can escape through this cotton wool. Some of the gas may be trapped in the syringe, but some of the gas will escape. So 1 will not work. What happened? Method 2, as the reaction occurs, the gas will escape through this cotton. As the gas will escape through the cotton, the mass will decrease. So we can use this technique, measure the change in mass with respect to time. Experiment 4, the third will not work at all. Why? Because you put a stopper, so you don't allow the gas to escape, because change in mass will only occur if the gas escape from the mixture. And here stopper is there, so when a gas is released, it can be collected in a gas syringe. So 2 and 4 will work. Is it clear, this question? What is the reason why there is a cotton wool? What is the purpose of this cotton wool? Because you can also leave this open. Like I can also leave this open, but it might not be accurate. Why it might not be accurate? Because when some of the reaction occur, reaction might be a violent reaction or explosive reaction. So it might cause a splashing of the liquid. So if it causes splashing of the liquid might come out from the flask. So if the liquid will come out from the flask, your experiment will not be accurate because you want the only the product, the gas to escape. You don't want liquid or the content of the flask to escape. So as you don't want the content of the flask to escape and you only want the gas to escape, that is why you put a cotton wool. So if they ask, give reason why a cotton wool is used, why the flask is not completely open. So it does not, the cotton wool does not allow the cotton wool will not allow the content of the flask to escape. This is for the safety as well as for experimental accuracy. Because if cotton wool is not there, if there is due to splashing of the liquid, some of the liquid or content of the flask may come out. So that will experiment also not accurate. So both it's related to experimental accuracy as well and reducing a or as a safety measure as well. Question 2. What could be the answer? Which statement explain why increasing a temperature increases rate of a chemical reaction? So heat makes the molecule collide more often. That's true. Heat makes the molecule collide with more energy and more likely to react. Increasing temperature, lower activation energy is not affected by the temperature. It is affected by another substance which is called a catalyst. So A is the right answer. Activation energy is the minimum possible energy for reaction to start. It only changes when you're using a catalyst. Otherwise, it will remain same. If you're changing a pressure, you're changing temperature, you're changing volume, the activation energy does not change. Which equation represent reduction? Reduction means gain of electron. If the ion gain electron, the charge should decrease. Which represent reduction? You remember from oil rig, oxidation is loss, reduction is gain. It's not A. Why it's not A? Because if iron 2 take one electron, then it should be iron 1. Because it's a 2 positive, it took one of the electrons, so it will become 1 positive. So that's why A is not a right answer. C is the right answer. Iron 3 take one electron and change to iron 2. Is it